Okay, we are balancing this equation, and this is a redox reaction. And we know it's a redox reaction because basically during a redox reaction the oxidation number of the elements are changing. Not for all of them, but for some of them they will change. And here the ones that are easier to recognize, for example, here is the chlorine, the molecular chlorine on the product side, because chlorine is by itself, this is an element, and an element by itself the oxidation number is 0. And whenever you see an element associated with another one, the oxidation number is going to be different from 0. So in this case, in the reactant side, that's the one that matters the most. Here the chlorine will have an oxidation number of -1. So chlorine went from -1 to chlorine 0. Okay, so that's the first change when it comes to redox reactions. Because you have the molecular chlorine here and you have these two down here, you keep the subscripts when you're doing this, the half reaction method. Then you have to put two chlorines there to make the equation kind of balanced. You are balancing the atoms in that half reaction. So you have two negative charges here because you have two chlorines. You have 0 coming from chlorine here, so that means that chlorine is actually losing 2 electrons total. 2 electrons because if you have 2 minus here on this side, you need 2 minus or -2 on the other side. Okay, so that takes care of the chlorine. So what is the other element that is changing oxidation numbers? Hydrogen is one that usually, unless it's molecular hydrogen, will not change. Oxygen is another one that will not change. For oxygen, usually the oxidation number is -2, and -2 there. For hydrogen is +1. So those two are not changing. So the other ones are lead and chromium. Now lead, in this case, chlorine is also in these two compounds. Chlorine with metals is -1. Therefore here lead is +2, and chromium here is +3. Now in this case, in this particular compound, the lead chromate, then lead is also +2 because the whole charge of the chromate ion is -2, not because of the oxygen but because the whole, chromate, the whole charge of this is 2-. And in that situation you have chromium with a +6 there. So the oxidation number of chromium there is +6, in the product side is +3. So we take the chromium down because it's the one changing. Lead is going from +2 to +2, nothing is happening to lead, so we leave it alone. So for chromium we are going from +6 to chromium +3, so you have a total of +3 on the product side, you have +6 on the reactant side, so you need to add 3 electrons here. So that now -3 and +6 give you +3. Okay, so these two half reactions are balanced. Now you have to make the number of electrons being lost and gained the same. So we take those two reactions and we multiply the top one by 3 and the bottom one by 2, which means now this is 6Cl- that goes to 3Cl2. We worry more about the molecular chlorine. In a minute you will know why. And here we have 2 chromiums +6 that go to 2 chromiums +3. And because the electrons are equal, you will have 6 electrons, you cancel those out. Okay, this is going to cancel with this because this went to 6, so was that one. Now we take these numbers, we're going to take these, and this, and we're going to replace those on the overall reaction. So we have, you have to put a 2 in front of the chromium 6, so that is 2 lead chromate. I'm going to leave the HCl alone for a moment. I'm going to leave the lead chloride alone for a moment, but I'm gonna change the one for chromium 3. This one has to be 2 CrCl3, and the molecular chlorine is this one here, has to be 3. And I'm gonna put water here. I'm gonna leave water alone for a moment. Okay, so now we are focusing on this partially balanced equation. Now these two numbers here that you put there, actually these 3, you don't want to change anything related to those compounds. They are fixed. You don't changing anymore. You are not gonna touch them anymore. So you have the others to balance the rest of the equation. So let's go back here to this one. This is telling you you need 2 leads. So this one has to also be 2 leads. So we're gonna add 2 in front of that lead chloride. Now the lead is balanced. Now this also is telling you that you need 8 oxygens, because 2 times 4, that's 8 oxygens. You only have water here, is the only one in the product side that has oxygen, so you need 8 on that side. Okay, once you do that, it's not necessarily that you can change it, you cannot change it, but you want to leave it alone for as long as you can. I mean, if you cannot balance after changing those numbers, then you have room to play. But out of that one, this is telling you that you need 16 hydrogens. And because you have 16 hydrogens there, that's why you put a 16 here on the hydrochloric acid. Okay? Now, the last to balance here, this is telling you, let's change the color here one more time. How about we use orange? This is telling you that you need 16 chlorines. Okay? Now you have 2 PbCl2. You have 8 here. You have 2 CrCl3. You have 6 here. Sorry, made a mistake. This is 4. Okay, and you have 3 Cl2 here, which is 6. You add all this together, you have 16 chlorines in the product side as well. So everything is balanced. Your overall balanced reaction is 2 PbCrO4 plus 16 HCl, that goes to 2 PbCl2 plus 2 CrCl3 plus 3 Cl2 plus 8 H2O. That is your balance equation.